going to talk about the physics generators in RAM. So we'll go over what they are, list a bunch of the different generators that are available, to using them, and go through a whole bunch of examples on how to use them to hopefully convince you that it's easy to do a lot of things in ratpac right out of the box. And then we'll go through the structure of an actual generator in case you want to write one for yourself, and then talk a little about gsim, which is the all the generators use to get to do the Jam4 simulation. So first, what is a physics generator? It produces basically a vertex, which has the primary particles in the event that have specified times, positions, directions, and energies. And it's configured using either the ratpac database or your macro commands. And then gsim is used. All that information gets provided to gsim to give the initial conditions for Jam4 to simulate. Here's just the link to the documentation for generators. So here's a list of some of the generators that are available in ratpac. I don't think this is all of them, but you can see we have a whole bunch of different generators for different neutrino interactions, inverse beta decay, elastic scattering, others for radioactive sources, calibration sources like the americium beryllium source, or just general decays of whatever isotopes you may be trying to simulate in your detector. And there's also a cosmic ray generator, and then plenty of others as well, or things like an LED calibration source for just generating photons in your detector, for generating neutrons or whatever random particle you want to have in your detector. There are other things to like import, for example, Genie files or already produced ratpac files as well. And all of these are in the source code under Gen. So I'll just start going into examples of showing how to use a generator in a macro. And this is basically one of the simplest examples of how to just simulate some electrons in your detector, where the actual generator commands in your macro are here at the bottom. And so this one of the more common generators, you use the combo generator, which gives you several options to produce your vertex generator, position generator, and time generator, which you specify when you add the generator to your macro. And so the vertex generators, there's a bunch of different ones that create the particles. They set their momentum and energy. And so some of the options here are, there's gun and gun2, which will just fire whatever particle you specify in some direction. There's elastic scattering, inverse beta decay, photon bombs, which just emits photons in isotropically. And you can define energy spectrum in RatDB as well to produce particles in the detector. And so in this first example, we're using the gun generator, which just fires an electron here. Then the next thing you have to specify here is a position generator. In this case, we specified point, which will generate events at a single point. But there are many different options, such as fill, where you fill the volume that contains that point, or paint, where you'll paint, produce events on the surface of some volume, and other options as well, which are all listed here. And then last, you specify your time generator, which determines the time assigned to events when they're generated in your file. So in this case, we use a Poisson distribution, which will generate events according to the rate that you set And according to a Poisson distribution, you can also use uniform, where it will just create it every however many, however much time apart based on the rate you give it as well. I guess I should probably also mention that this last command tells you how many events to run. So in this macro, we would be simulating 100 electrons. So we'll go through the settings in this example, while also mentioning that each different option you have in these, vertex, position, and time generator has their own set of settings, but this is just an example to help understand the different options you have available to you in RAT. So the gun vertex, which just fires a particle in some direction, you specify the particle. Here's a list of the different particles that you can use, that you can generate from the documentation. So you see, there's plenty of particles, positive electrons, positrons, muons, ions, plenty of exotic things as well. And then you specify the momentum in X, Y, and Z, and the kinetic energy at the end. And in this case, if you specify 0, 0, 0 for your momentum, the generator will automatically make them isotropic in just random directions, which is what it's done here. Then the next thing, you set settings for the position generator, which is just X, Y, Z. For this point generator, that puts them all directly at the center of your detector. And then you have the time generator, which determines the rate. So here, simulating just at 2 hertz.
So if you find one particle, what does rate mean?
It's because you're simulating 100 of them, so it'll be the spacing between each of the individual simulated electrons.
If you do run beam on one, it won't do anything.
But the global time of each event starts at 0 when the particles fire.
There's a global time, and then also an inter-event time. So yeah, it'll be 0 time for that event, but you'll get an offset time for. Yeah, so each generator has its own settings available to be changed in the macro. Here's a link to the documentation. I think most of them are in the documentation, otherwise you might have to look at the source code. And now I'll just go through a couple different examples to try to show some of the things you can do with RAT pretty easily. You have a decent amount of flexibility and a whole bunch of options to simulate plenty of things just out of the box. So this first one, using this decay chain generator, simulate some bismuth 214 isotope, which chain in a so that's the first option here. The next option then is fill shell. So I can fill a shell between 2 centered at some point and between 2 radii from that point. And then again, I use the time generator. So this fill shell, so decay chain allows you to simulate decay chains. And there's a whole bunch of different isotopes available in RAT by default. Then for this fill shell, you pick the center of the sphere and 2 radii to generate events between, and then you specify the volume that you want it to be generated within. In this case, in the validation geometry, it's just the detector volume. And so this would produce bismuth 214 decays within this shell of radii in your detector. Yeah.
Does the detector need to match the same geometry as the fill shell, or what if they're different shapes, like a detector what's
then it will just produce events within the shell that is also within the geometry that you specified.
Bismuth 214 will decay then afterwards to something else, so the chain will carry on.
So does decay chain only do bismuth 214 in this case, or can you do like late chain uranium or like early chain uranium?
So I believe this decay chain is set up to continue the chain.
Oh, it's just until like lead. Okay.
Things further down the chain.
Decay zero, there's something called decay zero that will do a single decay.
Right.
So if you decay zero, there's like 214 or whatever, it'll
Yeah.
just do.
Just do bismuth.
214.
That's actually my next example.
Okay.
Okay.
Yeah, so the next example here using decay zero. So in this case, I use the snow geometry to simulate some decay, in this case thallium 208. And so using K0, you only simulate the thallium 208 and you set the background using this command here. And then I use this paint option. So it paints sort of the outer surface of the volume you specify. So 000 is sort of the inner D2O in the snow geometry. And so it paints the outside of that volume, which is basically the acrylic vessel in the snow geometry. So this allows you to, simulate things on a surface. Here's another example, using the ambi generator. So this will simulate the an americium beryllium source, which produces neutrons and gammas. And this one has its own generator, the ambi generator, which then requires you to specify position and time generator. In this case, I just set it to the center of the detector. So these are the same settings as the previous ones. And the ambi generator basically handles everything within it using ret-b tables. So you don't need to set any other options. Yeah.
In this generator, why you have not said the momentum and energy in the
In this case, the generator itself handles all of that. It loads ret-db tables within the generator to decide what energy to produce the gammas at and what energy to produce the neutrons at.
and for the isotropic, right? So you discuss like we have to get the momenta is could be zero, right? So if you want to produce neutron isotropically, so we should set the momenta zero. Momenta x, y, and z should be zero.
Sorry, what was
Isotropic first was
so the generator itself should handle that, within. So I actually do go into look at the ambi code specifically a little bit later, where it does generate, everything isotropically within the generator.
What about for the decays, decay zero, decay chains?
Decay zero and decay chain, those also produce the isotropy.
So like thallium 208, when it decays, the decay particles will be emitted isotropically from position that you specify.
But if you, sorry, so is there a default energy? Like if you don't set an energy, does that particle have a default? Is that something like is?
What do you mean?
Spectrum.
So in these.
In J-on, inside of J-on, if you don't specify an energy, everything's like 1 MeV.
Oh, so in this decay zero,
Yeah.
all of the decay, all the branching ratios and everything should be set, or at least many of them should be set so that, this thallium 208 will always decay by, the actual gammas that it would decay by. Okay. Except for MeV gamma.
No, I think that we get these again. We have it. Maybe it's like just one.
You mean like you want to simulate thallium 208, but only it's the gamma that it
Yeah.
produces? So if you know the energy of the gamma, you can then just use this, use the combo with the gun generator to just generate whatever energy gamma you want. If it's a spectrum, if say tau thallium-208, has a different, some kind of gamma cascade, but you don't want to ignore some other particles. I think you might think you'll need to like change things in the source code to do that, unless some generator might, already have some option to ignore. I think, yeah, just one last example is this elastic scattering generator, which is a vertex generator, it's a combo generator, but it has some other options here. One is commented out, the other is here, where you specify a direction, and then you can also specify where it gets energy spectrum by specifying a ratdb type, ratdb file. Here, there's the solar ratdb file, which loads the solar spectra, and then it gives an entry in the file for HEC neutrinos, and then the neutrino type. And then there's also something similar for a stopped ion source as well, implemented ratpac. So basically, this is all to say that there's a lot of generators in ratpac already that provide a bunch of different functionality to use out of the box. That all, each generator will have its own settings that most of which are documented. And so you can, just out of the box, run a whole bunch of different relations based on what we need.
You have, the last example, you have, using it'll like set a position at the center. What does that do?
Oh, that fills the volume that contains the center. So in this validation geometry, it's what water out to like something like that. So it'll fill that full 4-meter volume with random positions within it, isotropically distributed. Okay, so that's for actually simulating things. So if your main concern is just simulating things and looking at them, at the results, that's what you should need. But if you want to know what exactly is going on under the hood, or if you want to create your own generator, we'll talk a bit about generator structure and look at some examples in the generators themselves. They all inherit from this LG4 generator classes. And they can load information from ratdb tables, to try to keep an energy spectrum that you want to produce or something like that there. And macro lines in your macro, which set up different settings in your generator. And basically the generator will take that all in. It'll perform, whatever calculations you want it to determine the position, energy, direction, or whatever of all of the particles that it's going to generate. Generate more than one in coincidence with each other. The ambient generator will generate neutrons and gammas, for example, and it'll create vertices and particle objects for each of the particle, set all the properties, and then pass that information to GSIM so that it can be simulated. So here's some example code this is for the gun vertex gen, where structure, when it's constructed, it'll set some default values for the particle definition, the momentum, the energy, and everything. And then as you go further down, there's this set state function that reads in what you put into the macro and overwrites those default values. So when in the gun option, you get the X, Y, Z momentum that you input, and set those momenta in the generator. So it will generate this vertex object, set the momentum based on what you input, the energy momentum you input. I cut off if it's isotropic, it'll give you a random direction. Otherwise, it will use the momentum input. And then the position and time will come from the other generators that you specified. So here's some code in the GLG4 time gen, which, again, this set state reads in what you wrote in your macro, and the rate, all you're looking for is double to set the rate, and then it will generate times. Generate those times based on the rate you gave it. And then here's the example for the position, where again, takes in what you wrote in the macro with this set state, and we'll set the position, X, Y, Z, fixed pause, and then whenever it generates the position, in this case, it's just for the point. So it just sets the value to the fixed position that will generate at that point. And then after all that is done, it sets the mass, sets these primary particles in the vertex, and adds it to this event structure, which is then passed to gsim to simulate the event. So things, I guess I did already mention these, but I just want to reiterate that, that example right there, you only have a single event being created. So generators are able to create multiple processes at whatever times you need, like the AMBI generator or IBD generators, for examples of how to create multiple events at different times. And they can be configured by loading ratdb tables as well. So here is in the AMBI generator code, where it creates the neutron and the gamma separately, just a couple lines of code apart. Add the first vertex for the neutron and the next vertex for the gamma. And it also will read in a ratdb table, this AMBI N spectrum, to get different values from that ratdb table. In this case, the probability that you get a gamma, because you don't always get a gamma in what fits with the neutron in the AMBI generator. And so if you using that random probability, you determine if you're going to produce gamma or not. And then you choose whether or not to fill these particles and create them in your generator. Yeah, so I think that's all I have for these examples of how the generators themselves work. And last is just a little bit of information on gsim, which is sort of the interface between the generators and Geant4. So they get registered with gsim in this gsim's init function. So if you want to create a new generator, you'll have to add it in here, gsim code, and basically gsim will initialize the Geant4 run manager, set up your simulation environment, call the generator, which will produce all the vertices and particles, and add them to this Geant4 event structure. And then gsim will process the event and simulate it through Geant4. And that will end up being written out in your analysis. So that's all I have. See that ratpac has a bunch of different generators available for use to control a whole bunch of your different properties and hopefully simulate anything that, most of the things that you might need. Several different generators already available in Rent. If that doesn't fit your needs, you can always write your own generator and sort of GSIM provides this interface between the generators and Jam4 for simulation. And your macros allow you to control all of your generator settings.
Quick addition. So you can actually have multiple generator in the same macro. In case you want to say have signal and background, like simulate at the same time, you're trying to figure out how well you can extract your signal. So that's just a small addition.
Yeah, that is a good point.
We're firing two particles in the same event. So let's say I want, for example, I'm working on reacting neutrinos and I want to study some background. A lot of that is accidental background, where I have two completely unrelated particles entering my detector at very similar times in the same event. Is that something I can do?
It should be. I know that exists in the Snow Plus route.
Not sure.
Yeah, I don't remember if it's the way.
So I've been told the hacky way to do it is just simulate them separately and then shift the times so they coincide. But that doesn't feel very, very neat, but
You could certainly write your own generator.
right, maybe.
Yeah, so plus we wrote like a coincidence generator
Alright.
and takes two signals and puts them in the same event. But I don't think that exists in that thing too.
Thanks.
Yeah, it's a good, that would be a good feature that.